Welcome. In this lesson, we will learn how to use Performance Analyzer to analyze results and explain its key capabilities, including the panes it contains. In this practice, we will use the simple elevator.im model. Open the model and click on the Simulation tab. After the system compilation is finished, run and execute the simulation. Click on the Performance Analyzer button. 4 panes are available in the interface. Let's have an overview first. Run Statistics pane. This pane gives detailed information about the solver. Currently, there is no information. To get statistics, we need to place a Run Statistic submodel on the sketch. State Contributions pane. The pane enumerates all the state variables of the model and their contribution to the determination of the solver integration step size. Frequencies pane. It gives insight into the frequency content of the model. Discontinuities pane. It displays the discontinuities generated by some models. In each pane, you can select which run will be analyzed using the common drop-down menu. It will be applied to all the panes and to SimCenter MSim. In the following section, we will show how to use Performance Analyzer to analyze the results. Let's close the dialog. Move to Sketch mode and place a Run Statistics icon onto a blank place. Simulate the model again. The model is fairly quick to solve. Open Performance Analyzer. In Run Statistics pane, we see the information on the time step size used during the simulation, as well as the type of algorithm used. The CPU time is the real CPU time of the simulation process. We can also drag the elapsed time, which is influenced by computer activities, into the plot. By comparing the CPU time and the elapsed time, you can see if the time is spent by the MSim solver or by other processes. We could also check kinds of integration steps information. From the plot, we can see that the minimal integration time steps down at around 7 seconds. Drag and drop the line current total number of discontinuities processed onto the sketch. You can also see that this number increases continuously just after 7 seconds. That indicates that something is happening in the model after that moment. Check the displacement of the mass. We find that after 7 seconds, the counter rate dropped into the lowest position. In most situations, we check the CPU time curve, the number of discontinuities, the current and the minimum integration step. For other variables, we could also get the information we want. Move to the second pane named State Contribution. The State Contributions pane displays very valuable information about state variables, as well as listing all the states of the system. The list can be sorted by state number, controls, submodel names, and so on by clicking on the corresponding column title. Double-click on a state variable. A green label indicates which component this state belongs to. From the list and the contribute plots, we can see high controlled value and the most active over the whole simulation. Double-click on a line to highlight the component on the sketch, so that we can see components contribute the most to the integration step size. The Frequencies pane displays information about frequency analysis. An automatic linearization run is a specific run that produces information on embedded dynamics in a system over a simulation time range. The regular times are based on an increment defined by the minimal number of linearization. The default value is 2. Click on Start button. This means that one linearization is performed at 0 seconds, and another one at the final time. The additional times are based on a specific algorithm that detects events for which the solver encounters issues. In this case, it's at around 7 seconds. The content of the table can be customized by clicking on the gear shape button in order to choose the properties for the model reduction analysis. You can use a slider to select a time point of interest. You should look for higher frequencies, which are lightly damped. Here, we set the time selection point to around 7 seconds. Click on the mode. The top contribution states are listed in the falling zone. Double-click on a line to highlight the component on the sketch, so that we can see which components contribute the most to the mode. The last one is discontinuity pane. The different contributors and their relative contribution sizes are easily visualized via pie chart. Curve tab also shows contributions from the submodels.